Alrighty, so let's do some of these overly complicated moment of inertia and momentum problems, right? Our goal for this one is to actually use the relationship that torque times time is moment of inertia times change in angular velocity. And we've got some of the pieces here, right? The torque is 92.0 meter newtons, and the time is 13 seconds, right? And then I think we can tell from all of this what the moment of inertia is. So let's figure that out. This will be the initial moment of inertia. I'm going to write it down here. Initial. Okay, initial. Okay, and that's going to be the merry-go-round, which is 1/2 mr squared. And then for the child, if they say that there's a certain mass at a certain distance, what you do is you use the lollipop equation. So you say, okay, plus mr squared, right? We'll say that all of that child is at r, okay? Okay, so that initial moment of inertia is 1/2, and this is the merry-go-round. So the merry-go-round is 170 kilograms, right? And then its radius is 2.1. And then the kid, so remember the cylinder is, all the way from the center to the outside, but the kid is all of them, we hope, right, at some particular place, right? So it's going to be 54. Don't go take your child and press them into a cylinder. Okay, and they are at 1.8, right? They start off at 1.8, right? Okay, so let's figure this out. 0.5 times 170 times, because it's a cylinder, right? 2.1 squared plus 54 times 1.8 squared is 549.81. And that's kilogram meters squared, right? So that goes here, right? We'll find out in a moment here whether and that's radians per second, right? Oh wait, no, sorry, that's just seconds. Okay, and that's kilogram meters squared, and then we're solving for the radians per second. So I'm going to go this guy times this guy divided by this guy. All right, here we go. 92 times 13 divided by the answer I just got. That's 2.17529. 2.17529 radians per second, which is, of course, this answer right here. All right, and so that's the first one, right? We've got that, right? And then we've got this notion that the child is at 1.8, but they move themselves out all the way to the edge, living dangerously, right? So this is going to increase the moment of inertia, right? So again, the final moment of inertia is going to be 1/2 mr squared. And the merry-go-round won't change, right? But the kid is going to move out. The 54 kilograms is going to move out. Whoops, I'm putting numbers in suddenly, right? It's going to be mr squared, right? And when we plug the numbers in, it'll be 1/2 170 times 2.1 squared. And now the only difference is that now the kid, instead of being at 1.8, is going to be at 2.1 meters, right? So it would be 54 times 2.1 squared. This ought to be a bigger number than this, so let's do it. Okay, now I'm sufficiently lazy that I'm actually going to go grab the old number and just change the 1.8 to 2.1. All right, here we go. 612.99. All right, so this is our omega final. This is our, I'm sorry, not omega. This is our moment of inertia final. This is our moment of inertia initial, right? So now we just go I1 omega 1, right? Or I initial omega initial is equal to I final omega final. And we almost have enough room, right? So we go 549.81 times, let's see, as a result. I guess we want to know what's the initial. Okay, so this is what we're solving for. Equals, okay, and then our final is 612.99. And our final angular velocity is 0.45, right? This is going to be slower, right? We were going faster, and now we're going to go slower because they moved out. When you move your arms out, you slow down, right? So I'm going to take that guy times 0.45 divided by the 549.81. And I get 0.5017, so the omega initial is 0.5017 radians, or rotations, sorry, per second. Now, notice that this was rotations per second. So this will be in rotations per second. I'm not going to I don't think I throw any angular conversions at you. So whatever I give you, you can just use that answer in your answer, right? Now, of course, you could turn it into radians per second, apply this formula, right, and then turn it back into rotations per second. There's no penalty for that, but you don't have to. For sure up here, though, this has got to be radians per second. That has to be kilogram meter squared. That has to be meter newtons, because this is anytime you're doing torque is I alpha sort of stuff, you better do that, okay? Hope that helps.